Good morning, everyone, and welcome to today's webinar. My name is John McLean, and I'm a Sales and Marketing Executive at TruckScience. We're hosting this webinar in conjunction with the NTEA, and I extend a special welcome to all members joining us this morning. We partnered with NTEA in 2019, and this membership gives members access to our axle weight calculator at reduced rates. So EVs and other alternative energy source vehicles have been around for a few years now, and the trucking industry has invested heavily in these technologies. Because of the complexity of the industry, however, with all of the different applications commercial vehicles are used for, there is still work to be done around infrastructure, range, engine power, and more. In this webinar, however, we will focus on some of the weight implications of using these new technologies, and we'll be using two real-life examples to illustrate common scenarios where EVs are currently in use. We opted to go for two EVs rather than, say, a CNG example, as the overwhelming majority of inquiries we receive are about EVs. Depending on demand, vehicles using other energy sources could be the subject of a later webinar. Okay, so let's get started. First up will be a Peterbilt 520 EV with a garbage body, followed by a Lion Electric Lion 8 with a refrigerated body. So I'm just going to flick over to the TruckScience Axle Weight Calculator app so we can dive deeper into these examples. Okay, so as I just mentioned there, we'll first design a garbage truck operating in California. So I'll need to set up the regulations to validate against this. So I'll go up to my settings wheel and I'll go here to regulations applied and I'll search for California. But as you can see, 50 states are catered for at an interstate level, and a lot of states are catered for at a road state level as well. We're constantly adding new ones on request, and we have also recently released all of the Canadian provinces also. So I'll just search there for California. Oh, sorry, I'll clear the list first, and I'll go for California. State roads. And you can see here it's also possible to pin attributes that we might be interested in. So currently I've pinned the gross weight on the vehicle front as a percentage, and the gross as a percentage of GVWR, and the gross as a percentage of permissible there as well. And we'll check into that later on in our examples. We can also define ranges for particular attributes that our organization is comfortable with. So for safety and traction, we might have an internal limit we adhere to on the gross weight on vehicle front. So we can set that between, say, 20% or 100% or whatever you need to set it as. And I'll set that up now. I'll leave that as is actually for the later examples, and I'll click OK for that. Okay, so as I mentioned there, I will select a Peterbilt 520 6x4, and I'll go for the EV version of this spec. Okay, so now let's familiarize ourselves with the workspace here. So straight up here, we have a notification that the front and rear chassis weights of the default spec have not been provided by the manufacturer. So this varies between manufacturers. Some provide the weights on their bodybuilder portals, which we then include in the software, while others prefer you get them directly from the dealer. We cater for either scenario, so I'll go ahead and I'll just pop these weights in here. So the front axle weight, I'll go for 14,200 pounds, and our rear 8,300. Okay. You'll notice the weights are quite a bit heavier than the equivalent diesel spec, and we'll see how that impacts the overall payload of this vehicle later on. I have another notification down here that this vehicle has an additional 2,000 pounds allowance in California because it is the battery electric spec. And I can see that this has already been applied to the total permissible over here. For diesel-powered vehicles, the limit will be 50,000 for this particular overall bridge distance. Okay, so apart from this weights table on the right-hand side of the dashboard, Other items we can note here are the compliance indicators. These give us visual feedback on whether the design compliance with what we call our three pillars of compliance, which is the manufacturer's limits, the regulatory compliance, and the organization standards. So those organization standards are internal quality or safety standards that are not enforced by law, but are nevertheless desirable metrics to implement on a build. So as expected, these are all green. And I'll just click in here so you can see the data points that we pinned earlier. So there's our regulations like California, and our organization standards are there as well. So on the left-hand side here, we can see our menu where we can add our bodies, equipment, payload, and different trailers. On the right-hand side, we can toggle between different views, such as bridge view, the center of gravity view, and also our smallest turning circle here. Okay, so we can see the turning radius has not been supplied by the OEM on their bodybuilder portal. So I'll just add this now because we'll need it for later. So I'll add our track width on the front as 83 inches. And our turning ability will change the inner steering angle to 40 degrees. Sorry. There we go. Okay, you can see there it's now loaded onto the drawing. Just remove this. Okay, so I'll go back to my side view here. Okay, now since this is a vocational truck, and we don't have a traditional PTO from the transmission, we might need to add an ePTO to power the garbage body we're planning to add. The chassis provided by the dealer might well come with this pre-installed, but I'll add one now using one of our templates. So I'll go into our equipment here. I'll go to add equipment. You can see we have a whole different range of equipment that you can add. But for now, I'll just go down to other, and I'll add a template. If I had a DXF drawing of an ePTO, I could have imported that also to make the drawing more realistic. But using a template gives you perfectly accurate results. And I'll just adjust the dimensions of this. So I'll say the length will be 16 inches. Our height will be 27 inches. And our width, 20 inches. And we'll change our weight to 250 pounds. And I'll just position it here on the chassis. And just as I do that, just keep an eye on the weights table and notice how it updates on the fly. So I'll place it about, say, down a little bit. Sorry, I'll press it up a tiny bit. And sorry, it's a little bit more. Okay, so next I'll add a body, and I actually have a DXF drawing here, so I'll go ahead and import it. I'm sorry, I'll just give that a name as well. So you can see it comes up in the weights table as other template, but I'll just give it ePTO as a name. So it comes up nicer in the weights table. Okay, so now we'll add that body, which is a DXF drawing that I have. So I'll go down to add body, go down to garbage truck, and import our DXF. I'll choose my file, which I have here. Yeah, that's good. I'll drag it down onto the XY axis here so it imports correctly onto the drawing. Click next. For our length, we'll go for 279.6 inches. The height is auto scaled according to the length, so I don't need to adjust that. I'll go for my width here, which will be 96 inches. I'll click next. And our body weight will be 14,700 pounds. Our horizontal center of gravity, we can actually specify that in inches. So I'll go for inches and I'll go for 151 inches. The vertical center of gravity, we'll go for 30 there. Lateral center of gravity, 50 is fine for that. Our horizontal center of gravity of the payload, we'll specify that in inches again. And we'll go for 103.5. Next, and we'll save it. So I'll save it as webinar 2025. And we'll click Save and Add. Well, I'll just change that to a different April as well. Oh. Oh, I may have adjusted that body weight to be, yeah, sorry, that's 147,000 pounds, which is not correct. So I'll bring that back to 14,700 pounds. Okay, that makes a bit more sense. Okay, so now that that's there on the drawing, so we've got that there in the drawing. We can see now, we can see from the weight table here that our front axle here is fully utilized. And there is definitely some excess unused capacity there on the rear and also on the overall. So let's drag this body back a little bit. But just before I do that, we'll keep note of the payload here. That's just under 14,000 pounds. So drag it back a small bit. Okay, a bit too much, I'd say. Okay, now we're fully utilized on the total row, and our payload has jumped up now to 14,350 pounds. And now we're fully utilizing that extra 2,000 pounds allowed for EVs in California. So up to now, the software has been auto-calculating the minimum legal payload. So as an experiment, I'm just going to lock the payload and see what happens if we drag the body away from its optimized position. So I can lock it here by clicking that. And we'll note now when I drag the body in either direction, that the vehicle becomes overloaded, and that is indicated by our compliance dashboard there as well. I'll just undo that change. I'll go back on full screen, sorry, and I'll undo that change. Okay, so now that we've positioned the body, we need to reduce that after frame there to suit. So let's do that. I'll just go down to my after frame and I'll change that to 56 inches. Okay, and I'll also update the cab to body here, and I'll change that to 45 inches. Okay, so now if we look at the data points we pinned earlier here, we can see that we're full utilization here on the permissible, but we have some excess on the GVWR. So let's unlock that payload again. Go back to payload, unlock it. So let's unlock that payload again. So the software. Oh yeah, so let's unlock that payload and we'll change it to a state with less restrictive state on regulations like Colorado. So if I go up to my settings wheel again, and I clear that, and I'll type in Colorado. All right, spelling's not great today. Colorado State Roads. Okay. Okay, so we can see there now the payload was 14,000 pounds, and now it has jumped up to just over 19,700 pounds. But again, we can see that the front axle is still the limiting factor here, indicated by the 100% utilization score. So if we move the body towards the rear by just a few inches, and we can utilize see. Okay, we can see there we've moved it just a few inches, and now we get an additional nearly 2,500 pounds of payload. So this additional payload is freed up because we're utilizing more of the vehicle's GVWR to take advantage of Colorado's more generous allowance on the rear axle of 40,000 pounds, as opposed to 34,000 pounds that was in California. So moving the body towards the rear to gain more payload does not necessarily make operational sense though, since this will increase the vehicle's swing out, which could potentially be a safety issue for a truck operating in residential areas. So I'll just go ahead and undo that. So because this vehicle is operating in residential areas, it also needs to be maneuverable. So having that small turning radius here is desirable. The shorter the wheelbase, the smaller the turning radius. But the shorter the wheelbase, the smaller the weight allowance we'll get on bridge. We populated the turning radius data earlier, so we can have another look at the details now and configure our ideal wheelbase. This is a bit of a trade-off, but in this case, we are prevented from reducing that wheelbase further because of the location of these batteries. This is often the case with EVs. So if we're happy with this vehicle, let's remember that. If we're happy with this vehicle, we can go ahead and generate a PDF. And it has all the relevant views. A second. You can add all your relevant views to that PDF, and it has all your different information on there as well, like your regulations applied and your manufacturer's limits. That's the end of example 1 anyway. So Jens, at this point, I'll just ask if there's any questions before we move on to example 2.
There aren't actually any questions, John, but feel free to reach out on the by clicking the Q&A button at the bottom of your interface and ask us any questions that you have on the content or anything else that you want us to elaborate on.
Yeah, thank you, Jens. Yeah, absolutely. Make sure to ask questions, even if it's not specifically about EVs. If it's any other aspect of the software, please feel free to ask as many questions as you like. Yeah, okay, so I'll just move on to my second example here. So for the next example, I'll need to go back here to home. And we'll design a refrigerated truck for use in California again. So I'll go back up to that the settings wheel here and change Colorado back to California. State roads. And I'll keep these data points as they were on the previous build, as they'll be relevant again. So okay, and I'll go for our line electric 6x4, and I'll go for the line 8. Good. So note that these default weights now have been shared by the manufacturer, so they're already populated there. And also we have that note again that we've an additional 2,000 pounds allowance for this vehicle. And we'll get back to that later on. So we'll add our body now. Second. And I'll add a template, so a box body. And we'll add our fridge unit as well, so we can go back to our equipment and we'll go to refrigeration unit at the top there. Skip past it. And I'll search for our Thermo King T800. Okay, so we can see there immediately that this unit is going to interfere with the cab. So we'll need to increase the body height to address this. So if I go over here to body height, I can change this to 100 inches. And there now we're clearing that cab. So I'll also add a lift gate here as well. So again, we'll go back to add equipment. lift gate, and we've a lot of different options there to choose from as well, but I'll go for a max on. I'll add that on as well. Okay. So now that our configuration is complete, we can take another look at the weights table. Down here, we can see that the app has auto calculated the minimum payload for this vehicle in California to be 17,500 pounds roughly, which is highlighted in blue here. The other figure highlighted in blue is the utilization on the rear axle. This means that we aren't taking full advantage of the 2,000 pounds additional overall allowance for this vehicle, since the gross is only at 46,000 roughly pounds. So due to the relatively heavier rear axle weights on EVs, this is quite a common scenario. And some states like Arizona have started allowing additional weight to be spread over the axles for EVs, in addition to the overall allowance. Let's try switching here to Arizona. Just click here to California and clear that to Arizona. Yeah. Let's see what impact this has now. So again, at the bottom left, we can see the additional allowance provided in Arizona. And if we look at the weights table, we see now that has translated to about 2,000 pounds of payload. So we're up to now 19,651 pounds. So interestingly, we're still not taking advantage of that 2,000 pounds for the overall allowance, as the rear axle is still the limiting factor. So what would happen if we increase the rear axle allowance even further? So let's try adding another 2,000 pounds over the axles. So I can do this by overriding the Arizona regulations and setting this rear permissible to say 38,000 pounds. Okay, we can see there we got another roughly 2,000 pounds of payload, but we're still not fully utilizing the vehicle. So again, I can bring this up again to 40,000 pounds. Okay, there we go. So if it is pushed up by a further 2,000 pounds there, bringing it in line with the vehicle's GAWR, we eventually take advantage of the overall allowance and bring the payload up to roughly what an equivalent diesel-powered vehicle might be able to carry. So that's actually that example as well. Jens, have there been any questions since?
Hi, John. Yeah, I'm just busy answering a question there. It's around whether the CG of the truck can be reverse engineered from its dimensions, and the answer to that question is no. The software cannot reverse engineer that. You'd need to reach out to the dealer to get the answer to that question. Are there any other questions? Feel free to type them in there, and we can respond and perhaps answer them using the software.
Yeah. Well, I'll be going back to my slides in a minute, so now would be the best time to ask, but I can always go back during the slides as well.
I suppose now might be a good time also just to let people know, those of you that are users of the software, we are releasing a new update in the coming weeks. We're including validation on max UVW, left-right distribution calculations, and also the ability to mark up your PDF reports. So those are all three of those features have been requested in the last while. So we're releasing that update soon. Now another question has come in here: do all states have an allowance for EVs? So I'm not a regulations expert, but I believe that that on an interstate level, all states would provide that 2,000 pound allowance. But I'll get back to you. I'll get back to the person that asked that question, and I'll get our regulations expert to reach out to you. There's another question there. When will we be able to do more than two drop axles? So the current limit in the software is three drop axles, but a total of four axles on the rear. So that's another feature that's been widely requested, and that's I can't give you a timeline on that, but certainly it's up there on our to-do list. There's another question there. On the main screen, there are only a few displayed rows on the weight summary. Can there be more allowed rows so all items are visible? So the answer to that is yes. John, if you can perhaps demonstrate that by clicking the equipment view on the top right there, just one up, yeah, and if you can drill down on the vehicle there. In fact, on this example, all of the items are shown, but once we reach a point where the different items are kind of grouped together, you can always hit that view in the top right, and there's an equipment view that lists all the different components up to a limit of maybe 10 or 12 components, I think. So you can certainly drill down there. The next question is, does TruckScience support Jeeps and boosters for heavy haul trailer applications? The answer is no, we don't support heavy haul. Yeah, and that's something we've chosen to focus more on the up to class 8 with without the Jeeps, boosters, etc. The next question is, where can I find the chassis drawing? I'm not exactly sure how to answer that. So the chassis drawings, I'm not sure whether the question is about the bare chassis, as in, yeah, I mean, we obviously have an underlying library of chassis where John would have demonstrated earlier, selecting the different brands of chassis. And maybe, John, you can just bring that up again. But otherwise, maybe if that person could just clarify what they mean. So there you can search for the chassis that you need within our library and bring up the chassis drawing in that way. Are there any other questions or perhaps a clarification on that? Where can I find a chassis drawing question? Okay, John, I think that's all the questions.
Okay. Thanks very much for the questions. We'll move on. So with the slides, let's go back to the
Oh,
slides.
sorry, John. Another two have come in there.
Perfect.
How can
Yeah.
we calculate the tongue weight for the trailer attached? So that's a good question there. The software can calculate that automatically. Now, John, I'm wondering, do you perhaps have a saved calculation there with a pup trailer or anything like that?
Possibly. Actually, the previous webinar I did have this a good example.
While you're getting that up, yeah. So the tongue weight is calculated, and John will hopefully demonstrate that now in not too long. There, he's got it up
Yeah.
there. You can see that example now has a lighter vehicle with pup trailer and a bobcat, and you can see the tongue weight is annotated there, kind of in the middle of the drawing. It's saying tongue weight 800 or 709 pounds. So yeah, that's calculated as part of the software. Um, the next question is, what are the lightest trucks available in the library? Um, yeah, I mean, we have a wide range. I suppose the lightest trucks or commercial vehicles. Um, we'd also cater for vans, and fairly light duty vehicles. Maybe if that person asked the question, you could feel free to register for a free trial and even search our library. The trial is fully functional, and you can take a look at the trucks that are available in our library. Unless you have a specific one in mind that John can maybe look up for you. Um, so there's a question here on Ram truck chassis dimensions, if demonstration available. So we can John, maybe you can open up just take a look at the Ram range there. Um, and yeah, we have fairly comprehensive coverage of Rams. Um, I'm not sure now. Maybe you can just open a 4x2. Just search for a 4x2 under axle layout there, and yeah, you can just pick the top one there,
Yeah.
and let's see what comes out. Okay, so this is we also have the box elite version. So this would be an example of a lighter vehicle that the previous attendee was asking about. But yeah, we have a wide range of Rams, and even if there is one that isn't in our database, feel free to reach out to our support team by using the live chat at the bottom right, and they can certainly add that for you. So there's another question there. So other than the extra weight allowance for some jurisdictions on EVs, there is not really much of a difference in the EV versus diesel configurations, or can you point out any other differences? I suppose the biggest difference between the EV and the diesel configurations would be the weight of the batteries. So that's it becomes even more important to make sure you're compliant in terms of axle weights. When you're designing an EV. Um, and then obviously there's also issues around the batteries being taking up space on the chassis rail. You'd have to just take that into account when mounting equipment. That you need to mount them differently on an EV when compared to a diesel configuration. I'm not sure if that answers your question. Please let me know if you need more clarification there. Then there's a question here about, could you please do the same for an F-150 with topper and bed slide and a lightning? Maybe if I could, I'll just make a note of that question, and we can perhaps reach out directly to you and arrange a more detailed demo. I'm concerned that we might run out of time if we go delve too deeply into a new build. But we'll make a note of that question, and we'll get in touch after the webinar to arrange a personalized demo. And in general, I mean, if you would like us to run through something, more personalized build, feel free to reach out, and we can certainly arrange that. I think that could be all of the questions.
Yeah.
Maybe also just one last thing from my side, John, is that we'll be in fact both John and myself will be at the Waste Expo in Vegas in a couple of weeks, and Truck Science has a booth there, so feel free to visit us there, and yeah, we can provide more detail.
Okay, I'll flick back to my slides. So to sum up, here are a few things to consider when upfitting and utilizing EVs. So to start with, the regulatory allowances for EVs vary significantly between states. So the jurisdiction where the vehicle is to be used is very important in the design process. While states like Arizona already allow more weight to be spread over the axles as well as overall, upping the allowance over the axles even further would make EVs more competitive in terms of payload carrying capacity. While payload is not the only consideration, it certainly is an important one. Secondly, the vehicles are generally heavier than their diesel counterparts. Batteries are often spread across the chassis rail, moving the center of gravity further back, using up more of the rear axle weight allowance, as we saw in our second example. So with batteries being spread across the chassis rail, there is less space to play with for possible wheelbase and afterframe alterations, and the less space to mount auxiliary equipment and bodies. Finally, without the traditional PTO from the transmission of a diesel engine, we may need to cater for an ePTO when speccing vocational vehicles. This also has an impact on weight and chassis rail space. So as Jens was mentioning there, I've used the TruckScience Axle Weight Calculator to work through the two examples today. If you'd like to try the app yourself, please visit truckscience.com to register for a fully functional free trial, and you'll be up and running in under 5 minutes. And just before I fully wrap up there, Jens, I'll just throw it out if there's any more questions.
There is another question here regarding unsprung weight, but I'll get back. I'll ask one of the engineers to get back to that person outside of the webinar.
Okay. So I'll end this webinar shortly, but before you go, please rate the webinar and leave any questions or comments you'd like to share with us. If you'd like to set up a personalized demo of the app, just leave your contact details in the comments and I'll gladly set that up for you. Thanks for joining us today and goodbye.